Hello everyone, my name is Daniel Silva and today I'm here to present my PhD thesis plan. The title of my thesis is ForestMP, a multimodal perception system for robotics in forestry applications. In recent years, Portugal has witnessed some of its worst wildfires that resulted in catastrophic effects in local communities, such as property and resources destruction, direct degradation of the ecological systems and environment, and even human lives. The availability of large amounts of fuel in dense forests makes the Portuguese forestry land highly ignitable and favorable to wildfires. The harvesting of biomass and its utilization for energy purposes has an enormous potential to be a solution to reduce the risk of wildfires, as the yearly production in 2020 of forestry residuals is estimated to be near 2 million tons. Nonetheless, cost-effective forestry machinery is needed along with intelligent perception systems for harvesting the forests. Mobile robotics, combined with visual perception and remote sensing, have paved their way in the domain of forestry working machines. Nevertheless, navigation in a forest remains a challenge because there is a lot of information and factors to consider, like trees, lower vegetation, holes, terrain steepness, and global navigation satellite system signal failure. Therefore, reliable perception solutions capable of working in these conditions are needed to improve forest inventory detection and identification and consequently harvesting operations, navigation tasks, and inventory management. The objectives of this thesis can be discovered using two main research questions. The first one is it possible to detect and distinguish forest inventory in real time in all weather conditions and 24 hours per day for forest operations using multispectral image data, LiDAR data, and radar data combined? The second question is, can we use a multimodal perception system in path planning approaches to improve mobile robotics in forests and possibly achieve autonomous navigation? From these questions, we can now detail the main objectives of this thesis. The first one is focused on studying and benchmarking deep learning models able to cope with multispectral images. The second is about studying, benchmarking, and developing a sensor fusion method that combines multispectral images with LiDAR and radar data to attain a multimodal perception system for forestry applications, which is ForestMP. The third and last one is related to the integration of ForestMP in path planning approaches to improve robot navigation in forests. The robotic platforms where ForestMP will be integrated are shown in this slide. At the left side, we have Agrop V16, and at the right side, we have Agrop V18. Both were developed at Inestec. To develop this thesis, 6 tasks were created. The first task is about researching the state-of-the-art about multimodal systems in forest contexts. The second is for making object detection using multispectral forest images. The third is for combining images with LiDAR data. The fourth is for combining images with LiDAR and radar data, resulting in ForestMP. The fifth is where ForestMP will be integrated with path planning methods. And the sixth is reserved for writing the thesis. All tasks are spread over 4 years, as can be seen in the timeline present in these slides. This thesis will be developed at the Laboratory of Robotics and IoT for Smart Precision Agriculture and Forestry that is part of CRIS at Inestec. Regarding my curricular plan, it is shown in the table of this slide. At this time, I have completed the extracurricular unit, which is the Publins course about reviewing scientific articles. For the image processing and computer vision curricular units, I have submitted an article for MDPI Journal of Imaging that is pending reviews. This article is about forest tree trunk detection in visible and thermal images using several deep learning methods. For the Advanced Process Control curricular unit, the work is delineated, and I'm currently writing an article that will summarize the main advances in the multimodal perception domain in forests. For the remaining curricular units, the work is under development and will be published soon. These are the works that I have been involved since the beginning of the PhD. Currently, the initial developments that were made was about visible and thermal detection of forest tree trunks, thus achieving multispectral detections, as can be seen in the videos present in this slide. The next developments will be focused on combining the multispectral detections with LiDAR data to detecting forest tree trunks to achieve the first stage of sensor fusion that was mentioned earlier on this presentation. Thank you very much for your attention. I am now available to answer some questions.